Okay. So this is exponential functions number 3. There's only a lesson this week and 2 next week. You're done, right? Exponential functions we'll get through, I think, and that'll be about it. So exponential growth and decay. When you think of, go through some functions you know now. Tell me what a linear function looks like. Are you with me, Dennis? What's a linear? In the air, yeah, with your fingers, draw a linear function. So that's good. That's good. I think that's good. Did you just go like that? Yep. Right? A linear means what? What's the word that comes into your mind for linear? A line. So that's a function. It's an equation that when you graph it, it makes a line. You with me? What other functions do you know by now? What's another big one that we spent 22 lessons on? Are you saying quadratic? I heard like both of you at the same time. Are you saying a quadratic?
Yes.
Everybody say quadratic. And when you graph it, what shape does it make? The parabola. You with me? Okay, now you're into a third type of function known as an, everybody say exponential. What are you thinking of when you hear exponential function? Say it again. Exponent, good. That is the variable. The variable's now sitting in the exponent position. Do you see that? Totally different. You've never had this before, technically speaking. Probably you've seen them, okay? But technically speaking, you've always been putting numbers into that position, that power position. Now you're putting a variable in there. So as you crank through the x-axis, this t, if this is t here, or x, right? It's going 1, 2, 3, 4, 5. The power is accelerating. Hence, the curve now mimics what kind of event that's recent in your life that we now lost 1 million people in this country to? COVID. It's a spread of a virus. Okay, one person gets 2 sick. Each of the 2 get how many sick? 2 each. Each of those 2 get 2 each. You with me? Each get 2 each. You see the 2's adding up? Now, some of the variants, they don't just go by 2. They go by 10. One person gets 10 people sick. All 10 get 10 each sick. Do you see the numbers compounding? Do you see the curve not just going left? It's not straight anymore. It's starting to creep up, and all of a sudden it hits a point where it goes where? Straight to the moon, right? It goes straight up. And theoretically, if the virus is deadly enough, right? We all die. What stops us from dying? What stops us from dying? Mask. Yeah, because it stops the idea that now 1 is infecting 10. No, it stops the cycle. You with me? It doesn't keep repeating that thing, and it doesn't go up to the moon anymore. That kind of, it's a dead end, right? You guys know what a cul-de-sac is? How many of you shake your head yes if you know what a cul-de-sac is? That's a street. It's a dead end, right? It's a French word. I imagine it means dead end. I don't know. You ever gone down the street and it's not, right? There's no end to there's a dead end of the street. You have to turn around and come out, right? That's called a cul-de-sac. Do you know this? Does it sound familiar? A little bit? What do you call it? What do you call a dead end in the street? Just a dead end? Yeah. Okay. So there's one right here. You know, as you come up to the back side of the high school, right? As you come up that back, there's a cul-de-sac right there, right? It stops because there's a hillside below it. The street doesn't go through, right? Does that make sense? That's what the mask does. What else makes a dead end to the virus? Vaccine, right? Vaccine, mask, even 6 feet apart can slow it down, right? Doesn't transfer as well, whatever. You with me? And all those things may be controversial one way or another, but not really. In the end, they're slowing down this curve, right? In the end, you're trying to flatten the curve. That's what everybody's talking about. Okay, so back to this idea. There's the idea of an exponential growth, which is a virus growing, and exponential decay. Not really a topic in this class, except the math part is. What decays? What has an exponential decay? First of all, what does decay mean? I mean, you know what growth is, right? Decay is the opposite. It goes down, right? It cuts off, it ends, it terminates. You with me on decay? So have you studied the radioactive isotopes? Right, where they're emitting certain particles of matter, and as they emit it a lot at first, and then it slows down over time. All right. In fact, this is how you can use radiocarbon dating. How do we know the age of bones? we dig up bones in the earth. We check the amount of radioactive matter still in them, and we know the rate at which it dissipates, that isotope, and now we can measure the number of years that thing's been sitting in the earth. Does this make sense? You kind of with me on this? Okay. So let's stay on track. Here's the way it works. AB to the x power. This is a potential growth or decay function. We don't know which. There are some tests. We look at A. If A is greater than 0, what's another way of saying that a number is greater than 0? What might you call that number? If a number is greater than 0, what would you call it? If a number is less than 0, what would you call it? Negative, good. So if a number is greater than 0, what do you call it? Yeah, positive. You with me? I mean, this is a fancy way, the math way of saying positive or negative. And you are well familiar with positive or negative. Positive has a plus in front of it. We don't show it. Negative has a minus in front of it, right? So that's okay. B, if B is greater than 1 and A is greater than 0, the function is an exponential growth function. If A is greater than 0, the same condition, but now B is greater than 0 but less than 1. Give me an example of a number that's greater than 0 but less than 1. 0.5. What else? Somebody said point something else. What else? What's another example of a number that's greater than 0 but less than 1? There's more. Viri, give me a number. Greater than 0 but less than 1.
I don't know. Yes.
Ah, okay, nice. I appreciate that. What's another way to say 0.5? Half, a fraction. You with me? So a half is in there greater than 0, right? Isn't a half greater than 0? Okay, use money. Give me an amount of money that's greater than 0 but less than $1. Louder. Penny. More? Dime. Nickel. You following? You get the idea, right? It's between 0 and $1. Just pick any number. And if we use money, it's to 1 penny. But if you're using numbers, it could be to 0.000001 is still greater than 0, but less than 1. Fair enough? Okay. Go for 2 examples. Do you have now I want you to open your laptops back up. Go to Desmos. Let's look at this one here. First predict it from the rules. This is A, so A is 5. This one is B, 3/2 right here. Tell me about 5. Is it greater than 0?
Yes.
Yes, good. Thank you for answering quickly on that one. If 5 is greater than 0, good? Okay, maybe a little bit harder. 3/2. Is it greater than 1 or greater than 0 and less than 1? What's another way to say 3/2? If you have 3/2 of a pie, what's your favorite pie? Do you have a favorite pie? What's your favorite cake? Chocolate. Okay, fine. I'm in. Chocolate cake. All right. You've got 3/2. Tell me how many pies you got. I mean, how many cakes you got? How many chocolate cakes? You have 3/2. 1.5. Here's a half, right? That's one of them. You put the other half next to it. That's 2 of them. That's 1. You just made a chocolate cake. And then you got half more. You got 1.5 chocolate cakes. Fair enough? 3/2, right? I mean, on some of these, don't let your brain get too complicated. Just think about it in real terms, right? These are still old-fashioned real numbers. You can just go with it, okay? So, if it's 1.5, does that fit into this rule? Is it less than 1? No, right? It's greater than 1, so what kind of function do you expect this to be? Function is an exponential growth function. So what do you expect to see this graph look like in your mind? Can you picture it in your mind? Yeah. Do it with your finger. Somebody did already, and I appreciate that. That's exactly right. Graph it on Desmos and confirm your thoughts, okay? Type this in. Will it take f of t? I think it might. Just try f of t. If not, what are we going to replace the t with? We'll replace it with x, okay? But try f of t first and raise this to the t power. And if it works, it should work fine in Desmos, okay? If not, we can always switch it out with x. Okay, are you trying? Are you on Desmos? Are you trying? Are you trying? Go quickly. There's only one more after this. Are you trying?
Yep.
Are you trying? Is it accepting that? And then raise to the power t. There you go. Where is it cross the y-axis? Can you tell me? Can you see where it's crossing the y-axis right there? At 5 right here, right? So my graph's a little bit different scale-wise than yours, but this graph is going like this. Right? And it's going straight through all my numbers, I guess. It goes straight up like that. Right? So that's an exponential growth. Go to the next one. What's A? 25. What's B? 9/10. Tell me about 9/10. Does it fit, is it greater than 1? Or is it between 0 and 1? Between 0 and 1. What kind of function do you expect it to be? Exponential decay function. So something here, go ahead and graph it now. Do another box on Desmos. See if you can picture it in your mind what's going to come out. See if you can predict it first. See if you can predict. Are you trying it? Type quickly. Type quickly. And you can turn the other one off. You can just turn that other one off. Are you trying it? Are you on Desmos? Are you going? Go quickly. Going? Something's not right. Are you saying? Because I don't see it yet. Oh, click home maybe. Is there a home somewhere here? So it goes back to the original. Maybe we can't see it. There should be a home. Yay, there we go. So we were just off scale 1, right? What number does it cross to the y? 25. Do you see a pattern of where it's crossing the y? See the 5 here? Notice what it matches up with. The A. The A in this case, 25. And in this case, we can predict because 9/10 is between that. It's a decay function, so it's going to come down like this. Something like that. Whoops. Something like that. Okay? Kind of flattens out. Okay, is that enough to do Schoology? They're just going to give you either graphs or the equations. You're going to put them through the test. You're going to say, is it exponential growth or decay? If you don't know, you can always type it into Desmos. Right? Fair enough? Okay.